Welcome to today's lecture on percentages. I'm Drew Collip. In today's lecture, we're going to be building on your knowledge of fractions, decimals, and ratios and incorporate the concepts of percentages. As we learned previously, fractions, decimals, and ratios are a way to express parts compared to a whole or total number. Percents can be used the same way. The word percent comes from the Latin for by the 100. So we can think of percent as per 100. So in this case, when we're talking about a total number of parts, we're always referring to 100 as the number in the denominator. 100 parts. So try and remember percent means per 100. Let's examine how a percent is expressed as a decimal, a ratio, and a fraction. To convert a percent to a decimal, what we do is we find where the decimal point is. If you don't see it, it's located at the end of the number. What we do is we move the decimal place 2 spaces to the left, and then we put the decimal there. So 82% comes 0.82. Please note, you must put a 0 when you start a decimal number that has no numbers in front of the decimal. Do not write 0.82. That is incorrect. Make sure you place a 0 in front. Notice 0.82. We're talking about a number less than 1. Well, 82%. If you got 82% on a test, you didn't get all of it right. You got 82% of it right. Out of 100 total marks, you got 82 of those possible marks. Let's examine how 82% is expressed as a ratio. So we will compare 82 compared to 100. Remember, per 100. This can be simplified down by taking a 2 out of the top and bottom. 41 compared to 50. Finally, as a fraction, 41 over 50. Now this would be 82 over 100, but we have to write it in simplest form. So to reiterate, we're always comparing it to the value of 100% per 100. Remember that. Let's examine 5.75%. Here we find the decimal and we move it 2 decimal places, 1, 2. I then get 0.0575. Now be careful of that. A lot of students will forget the 0 and they'll write it as 0.575. That's not 5.75%. What you just said was 57.5%. So it is very important we put these zeros in as placeholders to indicate those numbers are in the correct place value. As a ratio, 5.75 per 100. Let's multiply both sides by 100 to get rid of the decimal. 575 compared to 10,000. We will now divide both sides by 25. 23 compared to 400. There's your ratio in simplest terms. Same for a fraction here. This would be 23 over 400. Lastly now, we have 125%. This is greater than 100%. Therefore, there will be a whole number there. Same rules apply. Find the decimal, move it over 2 units, 1.25. Again, you can see there is a whole and there's a part. Convert that over to a ratio, 125 compared to 100. Divide both sides by 25, 5 compared to 4. As a fraction, 5 over 4, which we could express as a mixed number, as 1 1/4. So these are all ways percents can be converted over to decimals, ratios, and fractions. Try and remember, we're always comparing it to 100. Let's look at some more examples here. Let's convert each of these percents into fractions, ratios, and decimals. 25%, 25 per 100. To simplify that down, divide the top and the bottom by 25. And here we get 1/4. As a ratio, 1 compared to 4. We find the decimal. We move it 2 spots over, giving me 0.25. Remember, if there's no number coming before the decimal, please put a 0 in its place. 175%, 175 per 100. Divide the top and the bottom again by 25. We get 7 over 4. As a ratio, 7 compared to 4. And as a decimal, we take the decimal, move it 2 over, we get 1.75. 3.5%. 3.5 per 100 is what that says. Multiply the top and the bottom by 10 to get rid of the decimal, 35 over 1,000. Divide the top and the bottom by 5, we get 7 over 200. As a ratio, 7 compared to 200. And as a decimal here, 3.5%. We take that decimal, we move it 1, 2 over. We have to put a 0 in that place. 0.035. Again, remember you put the 0 there. Don't write 0.35. That means 35%. That's a big difference compared to 3.5%. 0.4%. 0.4 per 100. Multiply the top and the bottom by 10 to get rid of the fraction. Now we divide the top and the bottom by 4. 1 over 250. As a ratio, 1 compared to 250. We take that decimal, we move it 2 over. So again, be careful. 0.004 is what we want to write. Those zeros, the zeros indicate that this is in the tenths, hundredths, thousandths column. 4 thousandths. 5.5%. 5.5 per 100. Multiply the top and the bottom by 10 to get rid of the decimals. And then we'll divide by 5. That's 11 over 200. 11 compared to 200. Over here, 5.5%, 5.5%. We move the decimal 1, 2 over, putting in a 0, and we get 0.055. 10%, that's pretty easy. 10%, divide the top and the bottom by 10. 1 over 10, 1 compared to 10. Then we have 10. Move the decimal place over 1, 2, and we get 0.10. Lastly, 0.1%. 0.1% per 100. Multiply the top and the bottom by 10 to get rid of the decimal, and there you have it. 0.1, we move this decimal place over, 1, 2. So as a decimal, this is 0.001. This is very important. Make sure you put enough zeros in so that your numbers are in the proper place. Here's some practice problems. I'm going to do A with you, just to show you how these will work out. Rewrite the statement using percent notation. Out of 10 voters in a province, 8 are registered as independents. Let's find out the percentage of voters who are independents. So we have 10 voters total, 8 of them are independents. So we have 8 over 10. What we want this number to be 100. To do that, we have to multiply by 10. Whatever I do at the bottom, do the same thing to the top. It doesn't change the value at all. 80 over 100. Therefore, this is 80%. 80% of voters are independents. One thing I'm going to point out here, we learned about proportions in a previous lecture. We can use proportions to solve this. Now, this is quite easy to solve just by multiplying the top and bottom by 10. But quite often, it can be more difficult. So let's try this now. We were given 8 over 10 as our fraction. I want to determine what the percent is. So percent, this is always 100. And what I don't know is what that percent is going to be. So that's my x. We cross multiply. 10x equals 800. Divide the top and the bottom by 10. And we get x being equal to 80. In which case, you can see it's 80%. So there are different methods to solving this. For this problem, this was much easier, just converting the bottom to 100 and doing the same thing to the top. But later on, it's going to be more challenging, and you're going to have to set up a proportionality statement to solve it. I would like you to now try B, C, D, E, and F on your own. Give these a try, then I'll take them up. Let's convert 48% over to a fraction. 48%. Divide the top and the bottom by 2 to try and simplify it. 24 over 50. Notice I can do it one more time. Divide the top and bottom by 2 again. And we get 12. Remember, these must be simplified down. 29%. 29 per 100. Final answer. Can't be simplified down. Write 41 as a percentage, 0.41. We move the decimal place over 1, 2. 8%, 0.08. Move the decimal place 1, 2. Don't forget that 0. Very important. Convert the following percentage to a decimal and a simplified fraction. 0.28 as a decimal, 28 over 100. We can take a 2 out of the top and the bottom. I can see that right off the bat. And if you don't see it the first time, you can take it out again. I could have taken a 4 right off the bat. So in this case here, I have to do it again. 7 over 25. Hopefully these ones weren't so much of a challenge. Question E might have been more of an issue. So let's convert 333 1/3% into a mixed number. This is actually a mixed number, but it's written as a percentage. What do we have when we have a mixed number? Let's convert that to an improper fraction. So we take the whole number, multiply by the denominator, add the numerator over the original denominator. This gives me 333 times 3 is 999, plus 1 is 1,000 over 3%. What does percent mean? It means per 100. So per 100 is the same thing as saying divided by 100. So I can write this as 1,000 over 3, divide that by 100. It's the same as flipping and multiplying by 1 over 100. 1,000 over 3, flip and multiply. You can see we get that 0 cancels that 0, that 0 cancels that 0. And we're left with here, multiply the numerators, multiply the denominators. 10 over 3. Improper fraction. How many times does 3 go into 10? It goes in 3 times. 3 1/3. So 333 1/3% as a mixed number is 3 1/3. F now. Rewrite the percent in decimal form and as a fraction. So as decimal form, move that over to 0.285 as a fraction. 28.5% per 100. Multiply the top and the bottom by 10 to get rid of the decimal. I'm going to divide the top and the bottom by 5 now. 200 on the bottom, 57. So here's your decimal, here's your fraction. 5 1/3%. Again, let's convert that mixed number into an improper fraction. 16 over 3% per 100. Can we cancel terms out here? I can take a 4 out of this one. I can take a 4 out of that one. Multiply my numerators. Multiply my denominators. 4 over 75. There is your fraction. As a decimal, what does 5 1/3% really mean? 5.33333 repeating percent, which I could write that as 5.3 with a bar over top percent. Here I see the decimal. I move it 1, 2 spots over, put in a 0 as a placeholder, and here I get 0.053 repeating. Hopefully after reviewing this content, you feel more comfortable using percentages. What if we have a decimal and we have to convert it to a percentage? How do we do that? When you're converting from percents to decimals, you find the decimal place, you move it left. When you're converting from decimals to percents, find the decimal place, move it 2 places to the right, place the percentage symbol afterwards. In this case, the number should be getting larger. For instance, 0.56 as a percentage, I move this 2 places to the right. This becomes 56%. That's what 0.56 is. As a percent, 56%. Find the decimal, move it over to 3.0%. Please note, I wrote the 0 in. It's important. Very shortly, we'll talk about this in a lecture. If it was not important, it would not have been written in the number. 1.23, we move this over 2, and here we get 123%. And then lastly here we have a very small number. It's going to get slightly larger. Move it over to, we have 0.98%. I touched on this earlier when I was talking about using proportions to solve for these numbers. Let's look at that in more detail now. To convert one of these questions into a proportionality, here's our steps. Here, if we want to use proportions, we place the unknown value as the numerator over the denominator of 100. So remember, percent, this is always 100, always. Whatever is unknown, put that as x, and then place your percentage symbol after that number. So let's look at the example here. So write the following fractions as a percent. Here I have 2 over 5, and I want to convert that into a percent. Remember, this always remains as 100. What we don't know is what the numerator is going to be, this percent. Cross multiply. 5x equals 200. Divide the top and the bottom by 5. These cancel out. I'm left now with x is equal to 40. Am I done yet? I am not, because I have to add the percentage symbol. X is 40%. Notice right here, 40 per 100, 40%. So this is how we can use proportion to solve for these unknowns. And moving forward, you're going to have to do this quite a bit. Let's use this value now. It's a mixed number, 2 3/4. Convert that into an improper fraction. 2 times 4 plus 3 over 4 gives me 11 over 4. So here is my fraction. It says convert it to a percent. Remember, this always remains as 100. I want to know the percent. Cross multiply. Divide both sides by 4. X is equal to 275, which gives me 275%. Does that seem reasonable? This is greater than 100%. Notice we have a value greater than 1. So yes, that is reasonable. 5 compared to 9. Again, we're going to convert that over to a percentage. 100 is always on the bottom. X stays on top. Cross multiply. 9x equals 500. Divide both sides by 9. They cancel each other out. X is equal to 55.5 repeating. Therefore, 55.5 repeating percent. As you can see, the 100 always remains. The 100 stays as 100. However, the other three values change. We can solve for the percent. We can solve for the numerator in the other fraction. We can solve for the denominator in the other fraction. So let's examine how we do these three different operations. So again, when you're solving for percents, proportions are often the quickest way to go about that. Here's a trick here. You can look at this right here. If I'm asking for a percentage, I'm looking for you to solve the numerator above 100. If the word is refers to the number of questions, I'm asking for the numerator of the other fraction. If the word of is referring to the unknown, then we're looking for the denominator of the other fraction. Let's look at example 5. What is 28% of 951? Here, 28% is given. 28%. The question is, what is? I'm asking, what is 28% of 951? So the 951 is on the bottom, and our unknown is right here. Let's cross multiply. 100x is equal to 28 times 951, 26628. Isolate the x on its own by dividing both sides by 100. And here I get x being equal to 266.28. Final answer. If you want to double check, I could say 266.28 divided by 951. Plug that in my calculator. What do I get? If you did it correctly, what you should get is 28%, or in your calculator, 0.28. So there's always a way to double check your answer here. Some practice problems here. I would like you to try these on your own. Most of these are pretty easy. I'll just write down the answers. 15, 10, 3, 30. I'm going to take up E though. What is 83.5% of $565? So here we have our percent, 83.5% per 100. What is? This is the top number of, refers to this bottom number here. 565 over x. Cross multiply. 100x is equal to 47177.5. Divide both sides by 100 to isolate x on its own. And here I get x being equal to 471.775. What's my final answer? Here, I'm dealing with money. So I round off to 2 decimal places. Because that's how we do financial transactions. Let's look at something else now. Again, here is that equation. 403 is 124% of what number? So here we have 124%. That's given. Here's your 124 per 100. You can see 403 is, we're talking about the top number here, of what number? We're talking about the bottom number here. So here, I don't know the denominator in the second fraction. So that's how we set that up. Cross multiply. Divide both sides by 124 to isolate that on its own. X is equal to 325. And you can always double check that. 403 divided by 325. When you work that out, you should get 1.24 in your calculator, which stands for 124%. Some more practice problems here. Try these on your own. Here's A. Here's B. I'll take up C. If 6%, 6 per 100 of a number is 5.4. So is refers to the top number, of is my unknown, refers to the bottom number. Cross multiply, 6x equals 540. Divide both sides by 6 to isolate the x on its own. X here is equal to 90. Lastly now, 5 is what percent of 250? So here I have is, here I have of, and here I'm asking for what the percentage is. So again, is, that's the 5, of, that's the 250. In this case here, I'm looking to solve for the percent. So that's going to be my unknown. Cross multiply and divide both sides by 250 to isolate the x on its own. We can check that. I can plug 5 divided by 250 in my calculator, and I get 0.02, which means 2%. Number of practice problems. Try these on your own. Here's the answers to A, B, C, and E. Let's take up D together. What percent of 8.6 is 5.9? So here, what percent? That's what I'm asking for. So x over 100 equals of, refers to the 8.6, is refers to the 5.9. Cross multiply. Divide both sides by 8.6. What we get now, x is equal to 68.60465,116. That's what we get in our calculator. Is it appropriate to write this down? No. In the laboratory, when we're making measurements, you have to round things off because your equipment is only calibrated to a certain accuracy. We'll talk about this later on. What we do is we look at the numbers we're given. Those numbers have 2 significant digits. How many significant digits does 100 have? You might say 3. Wrong. 100 is an exact number. There is an infinite number of significant digits. going off to infinity. So what we do, we look for the weakest link. What's lower, 2, 2, or infinity? Well, 2 is lower. So we'd round this to 2 significant digits. So if we're rounding this off, we'll cover this in more detail very shortly in a lecture. I want you to do one more round of practice. The last ones were easy because they were grouped into, are we solving for the percent? Are we solving for the numerator? Are we solving for the denominator? Now this is all mixed up. So I'd like you to try these on your own now to make sure you understand how to build the proportionality. There's A, B, C, and D. Give those a try now. Let's take up A. What is 15% of 210? So 15%, what is, that's the top number, of is the bottom number. Cross multiply. Divide both sides by 100. $31.5. 25% of what number is 70? So here I'm given 25% of what number? Of refers to the bottom number. Is the top number. Cross multiply. 25x equals 7,000. Divide both sides by 25. X is equal to 280. See now, 20 is what percent of 43? So I'm looking for the percent. So X percent is equal to 20 is of 43. Cross multiply. Divide both sides by 43. X is equal to 46.51162,791. Don't round off until the final answer. Now your question is, if I was to round off, what would I round off to? Well, here, 43, that's 2 significant digits. 100, that's an infinite number of significant digits. Now we'd look at 20. Does that have 2 or 1 significant digit? That depends. Normally, 20, written like that, would be 1 significant digit. If we wanted to indicate to the person that the 0 was also significant, we could do 2 things. We could write the number 20 and put a bar notation over the 0. This indicates that this is a significant digit. Alternatively, what we do in science is we write it in scientific notation. And we'll be getting into that very shortly. So in this case here, let's just read what's given here. Let's say this is 1 significant digit, so this would round off to 50%. If it was 2 digits, it would round off to 47%. Communication is important, and you can see this number can be ambiguous, meaning it could mean one of 2 things. Did you mean 2 significant digits, or did you mean 1? Lastly, in a math class of 45 students, 8 received an A grade. What percentage of the class did not get an A grade? So here, I'm looking for the percent. There's 2 ways we can go about this. We have 45 students total, 8 of them got an A grade. I could solve it like that. However, that's not what the question asked for. The question asked for this number of students that did not get an A grade. So again, we're still looking for the percentage. Our class is still 45, but here, 45 minus 8. This will tell me how many students did not get an A grade. We can do it either way. Let's do it both ways. X over 100 equals 45 minus 8 is 37 over 45. Cross multiply. 45x is equal to 3,700. Divide both sides by 45. And here we get x is equal to 82.2 repeating. Over here, we can do the same thing. Cross multiply. 45x equals 800. Divide both sides by 45. Cross those out. X is equal to 17.777%. This is the students that got an A in the course. To find out the number of students that didn't, I take my 100%, subtract my 17.777%, and that gives me 82.222 repeating. So either way works. Just make sure you answer fully. The answer to this question is 82.2% of the class did not get an A in the course. So in today's lecture, we talked about percentages. We converted percentages to fractions, decimals, and to ratios. We also did the reverse. We converted fractions into decimals. Finally, we incorporated the idea of a proportionality statement to solve for an unknown, whether it be the unknown percent, whether it be the unknown numerator, which we can use is to represent that, or an unknown denominator, which case we can use of to represent that. We are going to build on this very shortly. That's all for today.